Hello everyone, this is Trista. So I'm happy to meet you and give a talk about how to create your distributed secure database ecosystem with your PostgreSQL instance. Here's something about myself. I'm the Trista Sophia ES co-founder and the CTO. It's my job title. My area, it's about the distributed database, about the data sharding, about the database and AI management platform developing. So I'm a developer. But apart from that, I love open source, and also I get involved a lot in Apache Software Foundation. I'm the member and incubator mentor to help to provide some ideas to other incubator projects. So today my talk will focus on how to use Apache ShardingSphere to create your secure and sharding database ecosystem with your PostgreSQL. So, if today you have some questions about my talk, you can contact me on the LinkedIn or GitHub or Twitter, any channel you like. Yeah, so let's get started. So today's content is just to solve one issue, the issue that how to create the secure distributed PostgreSQL database system. But before to import the solution, I just want to give some background about our PostgreSQL. Yeah, I guess most application will use the PostgreSQL in the second part. That means you will create the cluster with your PostgreSQL. You have the primary node and the one or more replica nodes to help to improve the availability of your PostgreSQL instance. Also, your replica nodes can get some or share some traffic with your primary node, right? That's the standard usage for the database. But in this classic structure or architecture of your database, we also can see more needs or requirements from the modern application or website. That means like high scalability or high availability. Also, you want to get your result as quick as possible, yeah? And also like how to get the elastic SQL out with your growing up your application, and about how to make your data encrypted and decrypted automatically. So that's the more needs or new requirements from the current your database architecture. So in order to solve such issues, I want to introduce a project, an open source project or community to help us to deal with such issues. That is the Apache ShardingSphere. So what's the Apache ShardingSphere? Yeah, that's the first question. I give the answer by myself. That is the ecosystem to transfer any database into a distributed database system and enhance this system with like a sharding, SQL, distributed transaction, or SQL audit, or more enhancement features around this distributed system. Yeah, that is definition or slogan. But actually, I will give more introduction about the features or architectures, but let me first add its community or this data on GitHub, because that is very important for us to pick up or choose this project. If it has a very active community, and that means you can get more help from this community. And that means this community receive a lot of user cases. So the same issue you may be met, but will be solved before. Yeah. So on GitHub, like this community or this project receive like more than 15,000 stars and have near 318 contributors now, and it released more than 14 versions. That means actually it's active or diverse, or maybe have a lot of the user cases, right? So that's the Apache ShardingSphere's community, and it's most developed by Java. That means if you interested in this project, or you want to get some the helps from the community, or you want to do some contribution to this community, I guess that's maybe it's a good project for you, like to join in open source area. Yeah, so because this project has been open source for more than 5 years, so I guess it's so mature for us to create your sharding Sphere or sharding ecosystem around your PostgreSQL or MySQL clusters. And if you want to learn more about this project, it has a website, Twitter, LinkedIn, any channel you can pick up. Yeah. So that's the community part. The next part, we will enter into the technique or about its feature or what this project can help us do. First, it's like the catalog of this project. Because this ecosystem, it has many features around your database. It has 2 clients or products for user to choose. Also, it supports many traditional DBMS. So here you can see for the feature parts, maybe you want to use this feature like read-write splitting, shadow database for your load test, and sharding, database gateway, SQL audit, or privileges. Any features I mentioned here, you can just use it and tell this system that you want to use one of these features. And you can use the distributed SQL or configuration YAML file to tell this product or tell this application that you want to use sharding, you want to use the database gateway. But today, we just focus on sharding and data encryption. There is the interesting part I want to mention that although you will see many of the features, but these features, apparently, they're independent, but you can use some of them together. That means you can pick up some features and group these features into a complete new solution. Yeah. So today, because we want to create a secure and sharding cluster with ShardingSphere, with your PostgreSQL instance. So that means we want to group sharding and data encryption to create our cluster. Yeah, so that's about the feature part. The next part, I want to say that this ecosystem or this community have 2 clients for you to choose. First one is ShardingSphere proxy. ShardingSphere proxy, like the gateway or like the proxy, it can help you do some computing or to handle with manage your traffic or statements or queries. But you need to independently deploy it. Like I side, like the second diagram showed you the second part. Here is the ShardingSphere proxy, the right column, right? You can see you need a server and to deploy it, and then your ShardingSphere proxy. And plus your PostgreSQL instance, they can group and become a distributed database. Because this ShardingSphere proxy, it works as a server, so you can use like a CLI or some DB admin tools to connect to the ShardingSphere proxy and use it as a standard PostgreSQL instance or server. And currently, this ShardingSphere proxy supports 2 DBMS. First, the MySQL. That means you can have a ShardingSphere proxy for MySQL. Alternatively, you can have the ShardingSphere proxy for PostgreSQL. It's up to you. Yeah. So today, we will choose PostgreSQL to become the storage nodes of this distributed system. Another product is ShardingSphere JDBC. It's a lightweight JDBC driver. So if you want to use ShardingSphere JDBC, that means it's integrated with your application. Your application and ShardingSphere JDBC will are deployed in the same machine or server. Yeah. But ShardingSphere JDBC, it implements most of the JDBC interface. That means ShardingSphere JDBC can support PostgreSQL, MySQL, Oracle, or SQL Server. Yeah, so it have more supports for your database. All right, so today, I say here, we choose the sharding, data encryption features, and choose the ShardingSphere proxy for PostgreSQL to create our solution. Yeah. All right. So, okay. So before we enter into the introduction of the solution, I want to give some case about how to understanding sharding with ShardingSphere proxy and data encryption with ShardingSphere proxy. What's the meaning of such issues? First case is the sharding, right? In sharding case, that means at the beginning, you have the primary node of your PostgreSQL, replica nodes of your PostgreSQL. But when you import the ShardingSphere or deploy the ShardingSphere, and all of the application just with the ShardingSphere proxy, that means the computing nodes. And the sharding the proxy will do some calculation and to locate which Postgres or in which instance it's for this target SQL or this target statement. So the ShardingSphere proxy will help you manage all of the shards of this distributed system. Yeah. But another case about data encryption. So what's the data encryption? Data encryption, in this case, it's not a distributed system, right? Because you can see here the application just with it one proxy, and one proxy will just with it one PostgreSQL instance. But it's a feature or function that it can help to decrypt or encrypt your privacy information automatically or internally. Here, like you have a table named the user table, and there is a telephone number column of this table. So you cannot store the plain text into your PostgreSQL, right? So the ShardingSphere can help you to decrypt this privacy info and then store it in the PostgreSQL. So here you can see the ciphertext of your telephone number. Conversely, if your application want to get the exact plain text of your telephone number, the ShardingSphere proxy will first get the target ciphertext and then decrypt the information and return the plain text to your end users. Yeah, so that's the function of this case. The last one I just give a mention, that is the database gateway. Database gateway, that means your here the computing nodes or ShardingSphere proxy, it's like the F5 or like the Nginx. It can help you manage your traffics or queries or statements. How? Here, you have two Postgres cluster. One of that, this primary nodes have two replicas. So you want proxy to automatically split or share your traffics among these privacy nodes and two of the replica nodes. Maybe 20% of the requests will be sent to the first replica, but the remaining 18% of the SQLs will visit the second replicas. But know about the whole the process of the traffic distribution. your proxy or ShardingSphere proxy, just to tell him that by your application about your rules or strategies around your traffic, then ShardingSphere can help pass the SQL and then send the SQL to the target replica or your primary nodes. Yeah, so that's the database gateway case. But today, we just use the sharding plus data encryption to help us to solve today's issue. So, entering today's case, we just want to create this cluster, distributed cluster. In this cluster, you can see that your application in the top level, and then your application send visit to your ShardingSphere proxy, that means the computing nodes, and then the sharding proxy do some calculation and pass your SQL, understand SQL, and resend this SQL or one SQL to one of the PostgreSQL instance, gather result, merge the result, and then return the final result to your application. But here, there are two features mentioned. First, it's the sharding, because imagine that your proxy have the logic table. I mean, the logic table, it's not the physical tables, because the actor table or the physical table located your two of the PostgreSQL instance, maybe named T user 0 from T user 0 to T user 1. And the same here in demo DS1, right? So there are two PostgreSQL demo DS0, demo DS1. They all called storage nodes. And the table, actual table, located in such PostgreSQL instance. But for your application, for your proxy, there are only one table, T user, right? So one T user, one table T user, it's mapping to 4 actual table or physical tables. Yeah. So that's the one needs. The next one is imagine this user have the privacy information, telephone number. Yeah. Telephone number. We need to encrypt the plain text and send it the cipher text into your PostgreSQL instance. So that's the encryption feature. So this case, you use sharding and data encryption together. That's the value of this case. Then, how to achieve that goal, or how to create this solution? Well, I gave the basic steps about how to create that cluster. First, you need to prepare your storage nodes. That is the two PostgreSQL instance. Second, you need to deploy one proxy. Also, you can deploy many proxies. You can group a proxies like the cluster. And maybe your case need more computing nodes, need more computing power. Then you can deploy more than one proxy instance to help you balance all of the traffics from your application or web pages. Yeah. So here in this case, we just deploy one. Yeah. And third step is to log in your proxy by the DB admin tools or GUI or CLI. Anyway, you can visit your proxy, or you can visit your PostgreSQL server, because as I before, proxy, it works as the PostgreSQL server, right? Yeah. So by step 1, 2, 3, you can create the architecture on the left column. Yeah. And then that means by step 1, 2, 3, you create a distributed cluster. And next one, you need to by using step 4, 5, 6 to fill this distributed cluster with the sharding rule, sharding strategy, encryption rule, encrypt strategy, or create many table many schema, many database on this empty distributed database. It's clear, right? So, how to tell this Postgres to create like a sharding table, not a standard or single table, to create a more table with the encryption feature. That means you need to use distributed SQL. Okay, I will give some details about this part. So by step 4, 5, 6, actually you make your cluster have the sharding feature, sharding function, and the data encryption function. So your application just visit this computing nodes, just visit the proxy, and this distributed system can help you automatically sharding data and encrypt your data, decrypt your data. Yeah. So the step 7 and 8, you just give a test or input or insert some data or records and to do some tests. So the next part or the later part, I will give the focus on step 2, how to deploy the proxy instance. Step 5, how to use distributed SQL to create a sharding rule and encrypted rule. And the last one, there are some highlights on this part with your distributed SQL. Yeah. So how to deploy your proxy? There are 2 ways for you to pick up. The first one, just to use the quick start on ShardingSphere webpage. It's easy, right? But there's a more efficient way for you to choose. That is, use the Sphere EX boot. ShardingSphere EX boot is developed by the Python language, and it can help you quickly one command to create your computing nodes and the governance center together. Yeah. So by use the Sphere EX boot, it can help you quickly create the cluster, the computing cluster, and with one command. So that's the efficiency of this product. There are 2 ways for you, and I also give your links for you to visit. After you deploy the ShardingSphere proxy, the next one that you need to learn and use distributed SQL. So, what's the distributed SQL? When this word mentioned the SQL, that means it's a language. Like talk about your PostgreSQL. If you want to make your PostgreSQL instance to work, like create a schema, create a database, create a table, you need to use Postgres and SQL dialect, right? And here, distributed SQL, it's a ShardingSphere SQL dialect. For your PostgreSQL instance, you have other language, other SQL like MySQL dialect, Oracle dialect. Here, it's the ShardingSphere dialect called distributed SQL. So you use PostgreSQL standard SQL to create a table, to create alter the table or drop your schema. Yeah, it's very simple, right? But you use SQL to communicate with your database, with your PostgreSQL instance. Here, the distributed SQL, it's the SQL-like statement. It can help you to communicate with ShardingSphere. Although ShardingSphere can understand all of the PostgreSQL standard SQL, ShardingSphere can also understand ShardingSphere SQL dialect. That means distributed SQL and advanced feature, advanced understanding capability. But why do you want to use them? Because, as I said, your ShardingSphere and plus your traditional DBMS, they work together and cooperate with each other to create a distributed database cluster or a distributed database. So if you want to use the database, if you want to use this distributed base to create some sharding table or distributed table, distributed database, and distributed schema, or like make this distributed system have some data encryption, SQL audit, or some distributed privileges. These advanced or the enhanced features, that means you need another language that distributes SQL to tell this distributed system. Could you get a point? To run well. Yeah. So you can here see some examples of distributed SQL. There, when you first give a glance, it's very similar to your PostgreSQL, but it's a little different, right? So you can just log in by CLI to run this distributed SQL to help you. Like I said before, you need to step 5. You need to run distributed SQL to create a sharding rule and encrypt rule, right? That means to fill more metadata or create a sharding table in this cluster, database cluster, sharding system. Yeah, so that's the distributed SQL. Also, plus it can help you manage this cluster. Here, like this case, at this case, when you run some of the distributed SQL, it can also tell you that this sharding system, it has two storage nodes and 1 computer nodes, and what status of each of the nodes. So use them to manage your cluster. Yeah. And I have no more time. So so here, all right. I introduced the distributed SQL and its value for this sharding system. You can see here like the show instance nodes to show you that what's the nodes in this system. And here I gave the complete test example or demo for you to create this architecture. But I have no time to introduce them one by one. So just give you the skeleton, like logging, add the resources or your storage nodes, and then create the sharding rule, sharding table by the distributed SQL, and insert some data for testing. And then here, when you run the select statement on proxy, you will see that all of the logic information, that this T user is a logic table, and you can get the text plain of your telephone number. But when you log in your physical PostgreSQL instance, you will find that all of the telephone number is encrypted into some string value. Yeah. And also, when you log in your actual PostgreSQL, you will find that there is no logic table T user, but have one of the physical or actual table of this T user named T user 0 or T user 2. Yeah. So that's the magic of this proxy, or it really helps user to deal with a lot of the process about the sharding, about the SQL audits, and etc. Yeah, so that's the complete case of this today's solution. And if you want to have a test, you can just copy and paste. And also, if you have any questions, you can just contact me on my Twitter or on my LinkedIn, or just visit the ShardingSphere GitHub and raise an issue. And also, I'm waiting for your PR maybe if you want to join this community. So thanks for your time. See you next time.